All right. Hi, everybody. I'm Lizzie, one of the Student Learning Hub coordinators at C2 Smarter. Welcome to this semester's first online Student Learning Hub, which is an education and workforce development initiative that offers applied learning and skill building opportunities to help you develop research and job-ready knowledge. Today's course is comprehensive urban data collection using drones, from licensing to advanced sensor application. Drones are becoming an invaluable tool for urban data collection, offering a wide range of applications from traffic monitoring to environmental analysis. This course will focus on how drones can support diverse urban data analyses, and will cover topics such as FAA licensing, airspace regulations, and practical drone operation, along with the use of sensors like cameras, thermal imaging, and LiDAR. And today's instructors are NYU's Toulon and Vivaldi Rinaldi. Tu received his PhD in urban systems from NYU in 2024 and his MS from Johns Hopkins in 2019. And he taught database management and cloud computing at Towson University in 2020. And his research centers on data-driven decision-making in resource management. And he is currently a research assistant at C2 Smarter, where he leads teams in forecasting resource requirements and optimizing allocation for the New York State and city DOTs. And Vivaldi Rinaldi is a PhD candidate in urban systems at NYU's Tandon School of Civil and Urban Engineering, and he holds an MS in Urban Informatics from NYU's Center for Urban Science and Progress, or CUSP, and a BS in Geography from Penn State. And his research focuses on the intersection of geospatial science, remote sensing, and deep learning. And with that, I'll pass it over to them to get started.
Okay, so
thank you so much. Yeah.
Thank you, Elizabeth. Hi, everyone. Welcome to our Student Learning Hub course about flying drone to collect urban data. So Vivaldi and we joined the urban system program since 2021, and the drone has been always a very powerful, helpful tool for us to doing our own research. And today we will be talking about the registration, performance, and research capabilities about the drone and the role of drones in the scientific process. And first of all, I have Vivaldi talk about how to pass the examination and the license, and get the license about the pilot registration map.
Right. Okay. So the Part 107 test is a mandatory test if you want to collect data for research purposes or essentially any commercial activities. It was designed by the FAA to do two things, actually, to evaluate the pilot's proficiency on regulations. So this is about the laws, things about your drones, how high can you fly, and the second thing is the procedures. So when you're actually in the field collecting data, what you should do. Management, it's more on the crew management and also your maintenance of your drone. And a large part of the exam is actually on the aviations, on the aeronautical knowledge, which is pretty hard, but it takes time to learn. The test itself is in person, so you have to sign up for at the testing center. It takes 2 hours to complete. The test fees is around $175. It kind of varies depending on which test centers you're actually in. The minimum grade you need to get is about 70%, so about 42 out of the 60 questions they ask. And you need to renew this license every 24 months, so every 2 years. And the renewing process is actually just an online test that you need to take. So once you get the actual license, all you need to do is just renew every 2 months so that your license can stay valid. Go to the next one. Okay, so what's in the FAA tests? First, the drone knowledge. A lot of them comes with the definitions, such as the visual line of sight, so like VLOS, your visual observer, which is it's like a buddy system where someone actually looks over the drone while the pilot's controlling the drone, and the control stations or the home base stations is where you take flight. Some of the laws includes like the drone weights, There is a specific requirements with which your drone should be. So if you are using like a generic drone such as DJI, it should automatically follows the law because they are designed to do so. A maximum altitude is about 400 feet above ground. And if you're working with a building, it's about 400 feet above the building and this side of the buildings. A lot of the documents, so your drone certificate, your drone registrations, so like your license or registrations, you always need to have this when you are actually flying. And then some of them part of the filing the damages. So there's a limit to damage that you need to file. I think it was $500. Above that, you need to write a report to FAA to let them know. And also procedures, drone maintenance, how often you need to maintain. There's also physics, a little bit of physics, just about like stalls and drags, just kind of like common knowledge on flying drones. Weather knowledge is this includes type of clouds, the type of wind shears. A lot of this comes necessary when there is a unexpected weather conditions when you're flying. And the last thing is the flight management. This includes the crew resource management. So essentially assembling a task team, flight team, where you assign one person to be the visual observer, or you want to pilot, and you can have other person helping out as well. Oh, where's our drawing? Is drawing supposed to be there?
Accidentally.
That's fine. Yeah, sure. And the last thing is behavioral traits. So they do ask questions. This is like what kind of a behavior you should actually have when you are doing the drone. So one of them is like machoism, something like that. Basically, it's essentially managing risk. And if you think if there's thing the weather is not good, and then you still want to collect the data, it's kind of taking everything into account. Next, please. So the aviation knowledge. This is essentially was designed to kind of give an appreciation to the whole aviation system and how they all work. So first, you need to know the airspace. There are many different types of airspace. This is very important when you want to plan where to fly. If it falls within a certain airspace, you're not going to be able to fly, or you can fly, but only a couple feet up in the sky. The second thing is the matter weather announcements. Essentially, this is really not you actually don't use it every day because this is more to an actual airplane flying kind of thing. But they do ask this question, so you need to know how to read this matter weather announcements. This next thing is the sectional charge, or essentially the flight maps. There are different types of symbols and legends that you need to understand in terms of like some for like military locations or air balloon locations. So this is something that you need to pay attention. And in the exam, they actually give you a booklet with this sectional charge, and then the question will refer to those booklets. The last thing is the airport runway procedure. So how does an airplane goes into the runway or takeoff and landings? So the Part 107 tests. Is it required for research? Because research usually fall within kind of a gray area, but essentially because it falls into, if it's like something to be published, yes. So you do need to actually have FAA 107 license. So once you do the tests, you pass with 70%, you will get this license, for example, license. And every time you fly, you need to always have this in your wallet or whatever. So how do you prepare for the tests? It's simply, so there's a lot of online resources. A lot of them are free. What I did was I watch YouTube videos and I write notes as if I was in a lecture class. And so that really helps me. I think I watch only like 1 or 2 lectures, and then I took the tests about like a couple days later, and that works, actually. And then they do have a lot of the FAA online documents as well, which you can refer when you are studying for that exam. But once you got the license and you have a clear research objective of areas where you want to fly, you need to, first thing, you need to always pay attention to local laws. So for example, in New York, you're not allowed to fly drones at all, but you can fly in specific parts of, a couple parks, I believe. One of them is the Culvert Falk in South Brooklyn, and as well as the Queens Meadow Park, I think. Yeah. And so in New York, it's like that. In Jersey, the law is actually, you're actually permitted to fly drones, but you need to still follow the FAA rules and regulations. And so to help you navigate through all this, there's actually an app by Alof. It's called the AirAware, where they'll tell you if you are restricted to fly, if this location is actually good to fly. The confusing thing about this app is actually that in New York, you can actually see places where you can fly, I guess you can see in the image. But again, you have to refer to the local laws before doing anything, because New York, there is no drone flight except in that, I think like there's 5 parks. So how do you, once you get your license, you need to, of course, register your drone. It's just simply going online and going to this FAA drone zone. Excuse me. And this website, when you sign up, you will have your Part 017 dashboard, which includes the your inventory, so how many drones you have, and also the user, so you can actually assign users under your license. Right now, we have 2 drones in the City Labs. One of them is the Mavic 2 Enterprise, which just expired last month. We haven't done any drone flights since then. Okay, since earlier this year, sorry. And so we also have the M300, which is a really big drone with a LiDAR scanner. Of course, they both have to be registered, and we do get as registering by adding the serial number, and then you will get the registration number, which I selected out for, of course, obvious reason. And so another thing that it's required now is the remote ID. So all drones that was produced after 2022 will have this remote ID. And since March, earlier this year, in March, you need to activate this function so that it can, when you're flying in an open airspace, and there are a lot of planes and all that, they can connect to one another. And so they can actually broadcast that you're actually flying there. So this is depending on where you are flying and the regulation of these local laws and the FAA laws as well.
Okay, so before we move into like practical flying skills, let me ask Viv a few questions. Like, Viv, would you like to share if during your entire like pilot career, have you met anybody like asking you for those criteria or certificates during your flight?
No, because we do have, well, the way I plan is that I find an open space where there's far from people. But I did went to Governor's Island one. I wasn't flying drones. I met someone who was flying drones for the government golf ball concert events. And I asked him about flying drones in New York because he was literally flying in the city. And he does get, he does have his paper from the government, from the local city government, to actually allow them to fly. So, it's something to always bring, all the certificates, license, and all that stuff.
Yeah, it's important to have all those certificates with you in your hand before a flight, and get prepared for it.
I do have like some people, although when I was flying, there are some people from far that were like, "Hey, can we record you?" I would say no, because it's it's a research project. I don't know if it's for commercial, if it's for recreational. I'm not sure. I mean, it depends on you, but I mean, for research project, I would not show that we're actually flying, because that could bring more crowds and stuff.
Yeah, indeed, and that's also related to like pick up or choose the appropriate point to take off. And we were going to talk about I think it's also important to understand the trade-off between data density and the operational difficulties. Let's look at the Puerto Rico as an example, because as urban informatics or urban science, transportation, or infrastructure researcher or scientist, you always want more and more data. You want the target area be as dense as possible. However, in those kind of area, you always have the most restrictions from all kinds of devices or facilities. So I will emphasize that you always look at the all kind of maps, not only from your pilot exam, but also from the DJI software or some third-party apps to find out the best location to fly the drone and to take off. If we look at the San Juan city's situation, you can see the city is overlapped by all kinds of restrictions. They might from the civil centers, airports, or other kind of infrastructures. So when I fly the drone at Puerto Rico, I just pick up all the closest point from right next on the edge of those restriction maps and trying to get the most dense data points as possible. And if we take like New York City as an example, like that they've just mentioned, actually, Viv and I, we have been flying the drones.
From Jersey.
Yeah, in Jersey City. I don't know if you can see these two little, straight land on the lower left corner of this map. Here is the point that was not overlapped by either the EWL airport or the restriction area from the New York City. So we can actually fly the
we did that
here. Yeah. So yeah, I would like to see always find out the like a smart place to take off and locate yourself smartly, because right now even the DJI software in your remote controller, because every time you fly, you will be connect your phone or any device into a drone controller like this, and the updated software within those controller will able to take over your drone right now. Due to any governmental or administrative.
It will lock you out.
Yeah, they'll lock you up. I mean, before maybe 3 years
before
earlier,
even flying.
you have complete control on your drone, but right now you don't. So if your drone enters any restriction area, the DJI app, they will force you to land pretty fast, under 15 seconds, the drone will just land vertically, no matter what is there, or if the drone is right above a highway or where it is. So it's pretty risky to enter those maps and have the DJI take over your drone. You always want to yourself completely take over the control of your own drones. And so if you already pick up an appropriate place to take off, I would say your personal safety is always the first priority. Just find a safe place to stand or to operate your flight. Because once I was in Puerto Rico to fly the drone to kind of capture the highway driver behavior, I was standing right next to the ramp, the grassland right next to the ramp. So there are two factors to be considered. A safe place to be flying. First is the kind of the environmental or infrastructure situation, right? You want to have a very stable place. There's no risk to be cover under any constructions, or you're gonna fall off or fall down to any places. And also pay attention to the I would say more social environment nearby. You want to be in a safer neighborhood to fly the drone. One thing in Puerto Rico, there's a lot of drivers when I was flying, a lot of drivers trying to I don't know, ask if I need a drive or pick me up for any purpose I don't understand. So yeah, we always pay attention to your personal safety first. And the DJI drone always ask you to calibrate the IMU or other kind of like procedure before you're flying. So sometimes you can skip those calibration, but I strongly suggest every time you change the battery, every time you change a place, do the calibration first before you're flying, because that will affect how the drone is going to behave after you like take it off. And sometimes the drone will be in the air for a long time, and you may have some very strong wind. And although the current version of DJI drones, such as Mavic 2, they are designed to be pretty wind resistant. But if you want to have like high quality like footage recorded or any other kind of data collected, pay attention to the weather. Or sometimes you can, when you try to select a right place to fly, you can try to find like a huge trees or building that can somehow block the wind that will influence the drone's flying. Battery life is also a very important factor to be considered once you are collecting your data. As an example, the DJI Mavic 2 drone, their battery, like one battery might enable you to fly for 15 to 20 minutes. However, I strongly recommend you leave more than like 3 minutes battery life to make sure the drone can be returning home safely, because there could be anything happening on the way home. So yeah, it's just keep your mission period within 15 or 17 minutes. Could be a like a safe play. And once you are collecting your data, also you need to pay attention to the storage, like where your data you're recording, whether it is a video, photo, thermal imagery, or LiDAR data could be stored. There is a like on-site storage. I think it might be only a couple of gigabytes within the drone itself, and there is a little place to insert a memory stick underneath. So every time you fly, make sure you select the storage mode to the memory stick, which might have a much larger space for you to store your data. You don't want, in the middle of flying, the controller said, okay, we're running out of space to store. So you can take it back and do a lot of resetting and send it up to the air again. And the last thing I want to mention about the practical flying skill is that, especially when you are taking the drone back to where you are, because you already flying, looking at the camera, looking at the controller for 15 or 17 minutes, you get used to like how it is to control from the your phone's screen. But you make sure you like take a look at the screen for a couple of seconds and look at the drone with your own eyes, like kind of do it repeatedly to make sure there's no other barrier up to the air or like the trees or building that will kind of crash your drone once you are like make it returning to your home place.
Yeah, so we're going back to the actual flight mapping. So the best way to actually plan for any kind of flights is to use the LF Airwear or an air control, which is a mobile app. So you can have it in your phone or you can have it in your iPad. So for example, here in our project, we were tasked to scan a school in Puerto Rico, which actually falls under a controlled airspace. But when we check the aloft, it says that we can actually fly for about 150 feet, so about 30 meters. And so because I have the license, what I do is that I download the air control app and then I request a LANC, LAANC request. And here I can say that I'm doing this for commercial, and then I specify what's the height of the flight that I will do, and then I would get authorization texted to my phone. So it's actually a pretty good system, just to make sure that if you are actually have a specific.
Oops. I think we lost Viv due to the internet interruption. Let's give him a couple minutes to rejoin.
Do you have other slides you want to bring in maybe first?
Mm-hmm.
Oh, they've actually joined.
Okay, perfect.
Sorry about. Yeah, sorry, my computer crashed. But yeah, so here essentially when you have you use the air control app so that you can actually work with the mapping. Can we go next too?
Mm-hmm.
Yeah, another one thing, we actually had a project in when we went to scan the lower Manhattan area. So we do have two cameras, one from Governor Islands, which is a proper thermal cameras, and the other one we actually found a piece of land in Jersey City, which is by the Colgate Tower, where it's not within any controlled airspace. And then we fly from there. What we did was that upward and then just scan for the lower Manhattan. I don't know if we can play the footage, maybe just like quickly for 10 seconds. And just skip forward, I guess. Yeah, there you go. This is actually when we're actually on in air and turn on the video. This is a terminal recording of the data of the area itself. And if you look down, that's actually where we are. And we didn't have any people around us, so that it's good. Because again, the foot traffic in this area is actually pretty low. Next.
Mm-hmm. Yeah, just one note here. You remember where? I think this Colgate Clugger will be a very good place to fly the drone if you want to monitor anything happening in downtown Manhattan remotely. But once we were flying there, there's a lot of helicopters, and they are flying so pay attention to that.
Yeah, and also you cannot go into the water. So if you're flying on the water, that's actually a restricted zone.
Mm-hmm. Okay.
Next. So yeah, that's what we did. One thing that I also did was to collect data for the other side of the government without flying. And so I had the drone on my hand and the controller, and all I did was that I hop on the Governor Islands ferry, and then as the ferry goes away from the pier, I start taking pictures. This is just for like another validation of the data. Another thing that pretty cool that you can actually do is that, so in our project in Puerto Rico, we want to study the heat stress that a typical school have in Puerto Rico. So we actually partner up with the school. We got permission from them to actually fly above the school during school hours. And the goal here was to compare to the images from satellite imagery, such as Landsat, which is about 30 meters per pixels, right? And so what I did is that I first of course, we do a manual fly around the school to create a surface model using photogrammetry, and then in order to create a systematic collection, I take the pixel size and divide them into 4 quarters. And for each quarters, I use the centroids to create points for the drone to take images from. And so I program this and input this onto the controller. And from there, I simply find an empty space near the school and I just click on go, and the drone just fly by itself. The cool thing about this is that once you actually put this onto your controller, they actually tell you what's the flight time. So it was around 5 minutes to collect all of the images, and then it will fly. Oh, you can actually program it just to hover, but I program it to fly back straight to the base stations. And so from there, I do have image patches of the school, and which then I can actually compare this to the very low resolution image from the satellite imageries and do some critical analysis.
Is it very hard to kind of code through this automatic flying mission?
I think so. There is actually a Python package that just, once you have the points in CSV, you export it. You have the table, the columns according to their specifications, and then it's just like a Python line, convert the CSV into this GeoJSON. I think it was a GeoJSON. Oh, sorry, a KML, and then you put that KML into your drone, in your drone controller, and that's it. Yeah. So the hardest part was kind of figuring out like where you put the points.
All right, thanks.
Yeah, and so the LiDAR, with the LiDAR one, this is actually pretty big drone. So on the two images on the left on the top are actually us testing out the drone in Calvin Park in South Brooklyn. We do have the antenna called the RTK bus station, which connects to the drone. And the lower one was actually in Puerto Rico. We wanted to do a LiDAR scan of electric tower. And so we couldn't really find a best place to fly this, and we found this empty land of plots. So we kind of have to fly in a lot of like grass around us. But because the drone is a little bit taller than the grass, it doesn't really cut the grass at all. We were able to take off. To process the LiDAR data, you do need to use these DJI Terra software. And then the one thing that I always do is that I take a picture of the settings before I fly, so that if there is any kind of offset that you need to apply, you can always refer to this data, because you can't really access it once you're not flying anymore. So I just take a picture and just input it manually. Thanks. And so yeah, this is the result. We do have pretty good data on the power lines, and so this is something that we're still studying. What I do with the LiDAR, I use the LiDAR R package to process and analyze. One thing to be noticed is that the actual power lines are very thick because of the LiDAR strength, and so I did some kind of we can actually reduce the number of points used that was collected from the drone itself to reduce the thickness. And so yeah, it's still an ongoing research. So it's pretty cool.
Yeah, I finished for this.
Yep.
Okay, great. So besides the LiDAR like capabilities, drone will also be able to do more mission in terms of like traffic monitoring. For example, this is once the footage I recorded back to January this year in Puerto Rico. We like if you want to be employ the drone recording into like traffic related studies, first you will need to find out like where the specific location of the road direction and connect it where you record it into the map itself, and compare to the drone flying map restriction. Here I gonna demonstrate like two kinds of areas. They are intersections, as the two arrows were pointed at, and all the ramps on the left side of the map. So you can actually, by your human eyes, you can see there's a flying height difference, because although those two highway ramps and the intersection, they're right next to each other, they belong to two different fly restriction maps. So on the highway, I can fly the drone up to say 6 meters high, and on the intersections I can do 120 meters high. So it's pretty tricky but important to understand where the restrictions to where you are recording. And if you're gonna record the video using the bird view upon the highway, you must be very careful because all the highway traffic, those cars speed up very fast, and if you crash your drone, not only you're gonna lose all your data, right? You're gonna also possibly cause some fatal accident. So make sure, like, when you collect traffic data, fly as high as possible, and do pay more attention to the traffic flow you're gonna facing. So here I'm gonna talk a little bit examples about the research potential of those drones. For example, if you want to analyze the traffic risk or the traffic behavior upon a certain section, you can use the drone footage, whether it's a picture or recording, to analyze how aggressive those drivers are and how they merge across the road markers. There will be like multi-lane crossing drivers, and there are some I see some ramp, like on-ramp or off-ramp parallel driving drivers, some like many other kinds of unsafe driving behaviors. And if you gonna use the drones to do like structural health monitoring, there's a very useful survey paper called LiDAR-based structural health monitoring applications in civil infrastructure systems. That kind of demonstrate all the related paper in terms of using airborne laser scanning into like road pavement, bridges, tunnels, art structure, heritage structure, and roofs. So traditionally, there were typical laser scanning methods, and right now we have more and more airborne laser scanning method. We call it TLS versus ALS. So some like traditional TLS do have a certain like advantages, such as you can have more detailed, more precise point cloud, and you can have better control over the capture point. Also, TLS-based technology, they were less complicated to operate than the airborne laser scanning. However, the airborne laser scanning can, first, as we've mentioned, can be like highly automated and can require less manual movement of the instrument, because once up in the air, the airborne has more space and freedom to move around. And it will also require less emphasis on each scan's angle and target, right? Because the airborne can move around and offer many possible scan angle, so you don't have to rely heavily on like a single angles compared to the TLS. And also you can capture more points as than in like a typical TLS scans, and it can capture some, it can reach out to some harder to reach targets, such as roof of buildings or underneath of the bridge structure, because in traditional bridge management there were monitoring team or conditional rating team sending out to each bridges every year or every couple of years to assess the condition of that bridge structure. And it's very hard to reach out like some top or underneath of the structure itself. So using help of the airborne laser scanning, you can do a more comprehensive, more detailed like scanning or monitoring structure itself. And also there are some disadvantages of the airborne laser scanning as well. First of all, you need to pre-planning the flight path, and sometimes those pre-planning paths were also required to get the certificate or the remote ID if you're gonna work on some like traffic or large infrastructure project. And those devices were more dependent on the weather itself compared to the fixed point DLS. And sometimes, as the last laser project that Viv demonstrated, the ELS points cloud might, you might have like abundance of data captured. So that will require more complex and time-consuming post-processing effort and methods. Okay, I believe that is the very last page of our demonstration today. So next we're gonna open to any questions about the drone data collection. Anyone, feel free to unmute yourself and
Yes.
Hello, hi, my name is Shiyu. I'm a PhD at Rutgers. Thank you so much for your wonderful seminar. I think you have introduced two types of drones. One is DJI Mavic that can do thermal image, and the other one that can use for LiDAR, right? So I wonder if there are any available models or any specs, like how do we choose the right drones for our research? I'm totally new.
Well, it really depends on like what you are trying to do. So we do have the LiDAR one, but it's now we can't really use it because the US government had sanctions on DJI so there's a restriction if you want to do scanning of any critical infrastructures. So power lines, we can't really do that anymore. So yeah, it really depends on like what's your research goals and what you're trying to do, and also the price is very different, right?
May I ask like how much those drones?
Yeah, the Mavic was around 4,000, I think 3,000 to 4,000. I don't remember. But the MTK one is I think above 20,000.
I see.
Yeah.
So yeah. So aside from the price, I believe you are like pretty satisfied with the data quality that you've collected with the devices.
Yeah, I mean, so with the Mavic 2 that we have is actually pretty good in terms of like thermal imaging. The only challenge was to actually navigate through softwares and processing the data that we actually can use. Because the thermal image, they give you a thermal image, and then you need to use their the DJI Python package to actually extract the pixel values and then use it for further analysis. So it's there is a kind of a pipeline to work with it. It's not as flexible as I want it to be, but it works. Yeah.
Great, thank you.
Any other questions?
You can also type your questions into the chat if you prefer. If not, we can just give it another minute or two and then we can wrap up. Any last takers? If not, thank you so much to Tu and Vivaldi for your presentations. A reminder that the recordings will be uploaded to our Learning Hub page. And speaking of the chat, I'm going to go ahead and put the link. I'll put 2 links in the chat. The first one is to the Learning Hub page where you'll be able to see this recording when it's ready, as well as all of our previous sessions. And then please join us for our next course, which will be October 25th, also at 1 p.m., I believe, entitled Where Are All the Robots and Why Aren't There More of Them? So I'll put that in the chat as well. And you can also find the link to that on our C2 Smarter website. All right, thank you, everybody, and have a great rest of your Friday.
Thank you.
Thank
Bye,
you.
guys.